Hi, my name is Ms. Kinner, and I want to give you some ideas for your Properties of Water project. You're supposed to tackle a new property of water, and ideally, this was something you learned about on Monday. But now that you've been working on your project for a while, I wanted to explain in further detail some of the new properties of water that might lend themselves the best to your project. So, those are the density of ice versus liquid water, six-sided snowflakes, cohesive and adhesive forces, high specific heat, and then lastly, I thought I could tell you about salting icy roads, just an idea for the solubility requirement. So again, I'm on the rubric here. Here's the solubility requirement. So I'll give you one little extra idea about that. And then here's where you need an additional property from the day one videos, the second to last requirement on the rubric. So let's talk about the density of ice versus liquid water. If we look at paraffin here on the right, usually solids are more compact and more dense and they sink in their liquid form. So solid paraffin sinks to the bottom of a beaker of liquid paraffin. But water's a real exception. We know ice cubes float on the top of our water because these molecules slow down, and normally they'd move closer and denser like paraffin, but for some reason water actually expands, and we can get an idea of that from this first image. So let's look at those images up close. I like this first one because you just see that the water in liquid form is pretty compact. And then in ice, it's starting to expand. Ice is less dense than water due to hydrogen bonds between the water molecules. Makes this hexagon structure. So look at how it's got 6 points and 6 sides and empty space in the middle. And if we look at it closer down here, we're going to see that slightly negative oxygens are attracted to slightly positive hydrogens by hydrogen bonding all the way around the hexagon. And we end up with more empty space in the middle so that ice will float on liquid water. Now, if we were to study graphs of the temperature of water versus its density, what we find out is that water is the densest at 4 degrees. And then if you keep cooling it past 4 degrees, from 3 to 2 to 1 to 0, it's starting to form its hexagons and expand as it gets colder than 4 degrees. So it's the densest and most compact at 4 degrees. And then cooling down lower than 4 degrees, it starts to form its hexagons with its empty space. And then its density actually starts to go down, and that ice will eventually be able to float. So lakes are going to freeze from the top down. The densest water is 4 degrees. So as air temperature cools down to 4 degrees, that 4 degree water is going to sink. And then when it gets colder out, that cooler water will stay on top, and then it's going to start to form those hexagons, and eventually that water on top is going to freeze, um, leaving this gradient of temperature where there's a 4 degree water at the bottom of the lake, allowing for fish to live at the bottom of the lake throughout that winter. And this allows for nutrient cycling through the water in the spring and the fall. It allows ice to float on rivers or on lakes, and organisms to really survive the winter down at the bottom of that lake at 4 degrees Celsius. It also leads to the six-sided geometry of snowflakes. So if we study our hexagons that are forming when ice forms, that's the foundation, that hexagon in the solid state's the foundation for the formation of six-sided snowflakes and all of our unique snowflakes. So all of that is due to those hydrogen bonds, from the slightly negative O to the next slightly positive H, making these nice little neat hexagons. And if water didn't hydrogen bond, we could imagine that might have an impact on our beautiful snowflake pattern and formation. Next up is water's cohesive and adhesive forces. So cohesion is the attraction between a substance and itself. So like how water is attracted to water by hydrogen bonding. Adhesion would be how water is attracted to something different. It's between different substances. So like water is attracted to glass. And this really explains the meniscus that we see forming on glass. For example, in our graduated cylinders, we see this meniscus forming because water is attracted to glass and can climb up that glass. And so, capillary action is really the rise of liquid due to a combination of cohesive and adhesive forces. Adhesive forces allow the water to go up the glass, and then cohesive forces allow the water to follow other water molecules. And this is really why water travels up plant roots and stems for plant growth.